Hello and welcome to this new video. Today I'm gonna solve the case of the MECC Teams Showdown that was featured yesterday live from the US, where four students university participated to win this tournament. It was, I think, University of Arizona, Kentucky, Tennessee, and Sydney, Australia, if I'm not wrong. It was a very nice show and a kinda hard game because it was based on this square to which you could apply shifts basically on columns, rows, and also to the center square itself. And that's pretty much it. So all the case is about those rotations to be applied. And already solved this case, but wanted to provide clean walkthrough to the solve. And yeah, so let's go. First of all, the thing I will say that I noticed is that you are provided with sequence of moves, and for the easier levels you have the move splitted. So what I will do right away is maybe move this one to the right and do a contact of this in order to have consistency in the input data. Same thing here, so concat this. And I'm probably missing the arrow. Okay. Okay. Example one, I need to remove this. I will try to build a general solution for this in order to have something very structured to go into level 7, which is the level which combines all the possible rotations, because otherwise you have horizontal shuffle, you have vertical, you have rotation, and then you have all together in level 7. The idea is I have in mind is this. So first of all, I'm gonna say position, magnitude, and direction. So I'm gonna split those. Okay, this is just one move, and I will need probably to shrink a bit this thing. Let's start from the square itself. Okay, so this is the starting square. In this level, I'm just gonna apply the horizontal shifts, but I wanna do that properly. So what I will do is I have X, Y, Z as possible options. Okay, basically here you're told, look, if you shift by X1 to the left, basically we're saying that you take all this thing, you go one left, and this goes here. So X is in position 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so A, B, C, same thing, I guess. So position, previous one is 5, is this -1, and from last, because I want to perform a take afterwards, it would be 1, 2, 3, 4, 5, 6, 7, 6, 5. Yes. Okay. Okay, what I want to do now is and also say direction, horizontal and vertical. Okay. What I want to do now is let position will be this, magnitude will be this, direction will be this. I'm gonna close this for a moment. I need to configure the, I think they were provided here, yes. So this is a -1, 1, 1, -1, 1, -1, okay. So I'm gonna call it sine, which is the x lookup of direction into those, returning those. Okay. I wanna also pull those data, so let's call this arrow. So the direction will be the x lookup of position into this, returning this. Okay. Okay. Then I wanna post location, x lookup here. Then I have other two lookups, which is previous position and from last position. Previous position is this one, and from last is this one. Okay. So now I want to say if direction equals horizontal. Yeah, of course I need the start grid to be this. No, this. If direction is horizontal, I wanna v-stack three things. I wanna v-stack the take of start grid until previous position. Not sure why it is not working for some reason. I wanna v-stack 1 and I wanna v-stack take of start grid minus from last position. There's something wrong with this. Okay. Okay. But instead of v stuck in one, I wanna rotate that array. In this case, I have a lambda for this, so I'm gonna transpose. It's called shift array. The array is the transpose of index of start grid. Row number is position location wall column, because it works vertically. To shift is magnitude times sign, and I'm transposing it again. Okay, so in this case, you see these 6, 7, 2, 4, 3. The 6 went on the other side. Beyond this lambda, behind this lambda, there is a simple take first portion, take last portion, depending on the shift. And okay, so example 1 asks for the sum of the, I think, the centerpiece as well, which is, I think, this one. Yes. See example 1b matches. Okay. So 34, 28, 32 seems to match the examples. Okay. Example 2 will simply do a text split. This over comma. Yeah, doesn't work in an array fashion. So up this, and I want a lambda a my splitter. That's interesting. Doesn't work. That is very interesting. I'm gonna put myself here. Okay. So this applies the first rotation. Now I'm gonna apply another one. I think I will go down. So this is before the rotation. We'll probably put a 1 here and say I want an index of those. This index those. This index those. this. Okay. I think we should be good to go. Okay. So it should be 37. And it is not. So this shift is Z by 5. Okay, then Z by 1. And then again by 1 by 3. Okay, do I need a minus here? Still 27. Yeah, of course. This is a 3. Okay, now here we are. So the sum of the centerpiece, which is this, date, and that's it. 33, 35, 40. Okay, level 3 asks for the same thing but on the vertical piece. So in this case we are not giving anything for the vertical, so we need to provide that. So in this case it will be the same thing, but an H stack of take the columns. I don't need to transpose anything now. So I'm gonna shift that index all the rows for this specific column and shift by this. And the DB stack was not needed at all, by the way. So we don't need it here as well. Okay. So in this case we're shifting on C by 2 up, and I would say yes. So let's sum the centerpiece. It matches. 3B, it matches as well. So here we are. 4 is same thing, but multiple steps. So okay, it matches. Let's go. Five introduces rotation. Basically, rotation says if you rotate by 1 counterclockwise, you just move around the perimeter. So it's not a full shift of the square, it's just all the pieces moving one in that direction. Very simple. So the way I will do that is I will need to throw any ferrule here and return the starting matrix. So basically now the last one is 35, which is equal to this, yes. So what I will do is to vstack. Basically the concept is that I wanna turn this into an array and shift it and then put it again into a square. I wanna keep it very simple. So first of all, the array will be the transpose of this, then this, then this, then this, then this. So array, and the shifted will be shift array this to shift is index of say this by this. I need another condition when I do the extract numbers of this. Okay. And I also need the sign. So let's say let array it is direction make copy all of this. So the array I don't need the position. The magnitude will be this by that. The arrow will be this. The start grid I don't need it, and the sign is that. So I shift array by magnitude times sign. Okay, so in this case we're shifting 10 steps, and I think that's enough because it asks for the top left one, which is by construction the first one. So this matches. Okay, that's curious. One. Okay. Substitute this, nothing. To do like this. Okay, hopefully we're good to go. 283, okay. Yeah, the fun thing is that I was way faster during the live solve because I didn't look for an optimized structure, but I think this will enable me to solve level 7, which I didn't do during the live solve. Now, 3 rotations, one after the other. I want to do that quick. So now maybe let's go for level 7 properly. So in this case it will be so it will be this, which isn't changed. It will be this, which isn't changed. This. And this. No. Because it's a 3 times 3. Okay, so this is gonna be this. Then I picked this. Then I picked this. Then this. Then this. And I need to pick the center one, which is this. And then I need to choose. So if len of index of this by this. No, it's not said. So if is number, find this into index this by this. Then I will take this, otherwise I will take this. Okay. 489. Okay, I think it's this one. For some reason. Okay, this was. Okay. Okay. And simply now I'm gonna go at this. Okay. This is going on here. Okay, there's simply not another step. Okay. And okay. It's an 8. I must for the top left. So 531. Okay. Apparently is correct. And now is where I'm gonna to have the dividends. Rotation shuffles are now applied within the sequences. What is the sum of all 9 numbers or phase after all the moves in each game? Okay. 2, 3, 4, 5, 6 moves. Most max. So level 7. Okay. Forgot to do this. So the sum of the square is 36, which is matching. Yeah, problem is I have a variable number of steps, unfortunately. So 1, 2, 2, for example, gives 2 more. 2, 3, 4, 5, 6. 4, 5, 6. So 1, 2, 8 is my worst option. Okay. So okay. So 6 steps. If I go back to example 7, which has not all those steps. Okay, I think is the same, 36. 36, yes. So I should sum the bottom right. No, something went wrong with game 1 to 2 for sure. Okay, so first of all, y2. So this changes. Then, okay. I have a 2 rotation. Yes. Then I have a b5. And it does that. Sounds good to me, to be honest. 2 counter, not 2 clockwise. Four, 1, 5, yeah. then Z3, which is no. This is not doing anything. Why? 3, 6. Yeah, that's why. That's quite annoying. Okay, now I'm matching the hints, so I'm pretty confident this is correct. Okay, bonus questions. Between the numbers 1 to 9, which number is found the most across row X and column A? X and A. I think including duplicates. So 2. From numbers 1 to 4, how many times did the direction that was used the least often appear? Get levels data 1 to 4. Take first column, arrows, transpose. I'm gonna count. The list is, well, 39, because the other arrows are not applicable. If I was 1 to 4, how many times did the number 8 appear in the final phases after applying the sequence of moves, excluding example 8? Excluding example 8, the number that appear multiple times on the same phase will contribute more than once toward the final count. Well, so count ifs 8. I'm not sure how many games are we talking about. 80. $64. Not sure. If exactly 2 moves can be taken, each shift by 1 unit, what is the highest sum of the values in the phase that can be obtained? It is the sum of all the shuffled values for moves given in levels 1 to 7. Maybe let's go for this first. So some extra numbers, this 1, 5 to 3. Okay. Exactly 2 moves, each by 1 shift. can solve this without even Excel, because I mean, if I move this direction, it means that I will have a 7 instead of a 4. And if I go the other way, I will have a 2 instead of a 2. Same thing here, so a 9 instead of a 4. And 3 instead of a 5. I go the other way. So I could just take the maximum 2, so it's a plus 11 to my square, which is 46, because the rotation doesn't change the value of the square. But if I do rotation and shift, yeah, but it means that I could have 9 and 1 as, I mean, best possible impact, which is a net of 8, which is less than 11. So I think that's the solution, but it would be interesting to solve it with Excel. It's the highest sum of the value in the phase it can be obtained. So it's like combining, I could have A, B, C, X, Y, Z, and I could have the directions. So I can combine those. And can combine again. No, doesn't even make sense, because no, it's not like this, because A can just go so ABC can go with this, and I need to go, and X, Y, Z can go with those. Okay, can concat, and these I can combine twice. So 144 combinations. Which I could, let's call it 8. So transpose index this and this. Okay, so direction 1 are coded. So this is a 471. this is not working. Because the magnitude is there, so it's left. This is 1 and it's right of this. Okay. And I wanna take the maximum after 2 shifts. So it's already 42, 46. 144. No. Need to change this. Yeah, I get 46 as maximum, so I think it was way easier to solve it visually like this. Yeah, hope the answers are correct, because I actually don't have the answers, and I hope you like the solution. As said, I was way quicker during my live solve. I got level 1 to 6 and the bonuses, except no, all the bonuses, and hopefully those are correct. I think with an extra 5-10 minutes, or if I would have been quicker, this model nicely scales, but I mean, it's quite complex to come up with this general structure during the time solve of 30 minutes. Let me know if you have any question in the comments, and thanks for watching. We'll see you in the next one. Bye.